Hey YouTube, JP Dillon. This is going to be part 2 of the General Electric CYA7342 WT. Over the weekend, I got the replacement high voltage divider block. There it is. It's the NTE HVD4 from Vetco Electronics. Took a little bit of time to get here, but it got here, so that makes me happy. So let's get right into it and tear this thing open and see what's involved in replacing it. So as you can see, there are some differences in the physical size of it, but the mounting points appear to be the same. Basically what this is a 300 mega ohm 4 watt resistor tapped at about 50 mega ohms, which then goes to the focus control, and then the other part goes to the focus lead on the CRT. So hopefully it's just a matter of swapping things out, and it shouldn't be too much more complicated than that. I couldn't get the exact part, but this seems to be the closest based on catalogs of things that I've read, cross-referencing original GE part numbers to ECG part numbers to NTE part numbers. So yeah, it should be just a factor of unsoldering the focus lead, and then we've got the jumper here to the CRT. It's weird how they do that, but whatever. And then we've got the anode connection to deal with. We're going to discharge that first before we take it apart, and then we'll see what's really involved. So basically my discharge rod is just a screwdriver with a clip lead that I then clip to ground. And you want to look at whatever instructions they have to discharging it. They say do not draw arc when checking for high voltage, blah blah blah. Let's see, they want the high voltage 27.5. Wow, that's pretty high. It's usually about 25. I don't see any instruction here, so usually what you do is you do it to chassis ground. So what we'll do is I'm just going to clip this onto the chassis here, and I'm going to slip this underneath the connector, and we should hear a nice little snap if there's voltage there. And I don't hear that, but I'm going to hold it there for 30 seconds anyways. Better safe than zapped. I've been zapped. It sucks. Been zapped a lot. I always thought it was discharged, and it's not, so I always check with a meter, although this one doesn't appear to have any voltage on it whatsoever. It's been sitting a couple of weeks, so it's probably discharged. So now I have to take a look underneath here and finagle this off, which is going to require 2 hands, and then we'll see how it's dressed up in there. Okay, so once we took the high voltage button off, there's a screw underneath that's part of a clamp. You undo that screw, and then you can pull the leads out so that we can change them. So now all I have left to do is take that hardware loose, unclip the focus lead here, and unsolder it from the pot there. And then I'm going to obviously have to solder this because I don't have a terminal, a push-on type thing here. We'll get that all in there and get it reinstalled, and then we'll fire it up and see what difference there is in focus. And I'll take some measurements on the old one and see where we're at with that, because I'm pretty sure that one's got an open. So let's get to it. Now, I really don't have a meter that tests the full capacity of this, because this one only goes up to about 80 meg. So I'm not going to show anything between the high voltage input and the other 2 leads. However, I might show something between the tap and the ground side, which is the black lead. So let's see if I get my 50 ohm tap here. Let me hook it up. Alright, I'm going to try to hold the camera and do this at the same time, which is going to be tricky. So bear with me a second. So if I measure from the tap to ground, on the 80 mega ohm scale, I still don't get squat. So this thing is open. Not even kind of sort of close. I should be getting something. I mean, if part of it was open, I'd at least get something from the white lead, which is the 50 ohm tap, to the high side, or 50 mega ohm tap rather. But as you can see, no matter where I place the meter, it's open. So this is definitely defective. So let's get the new one in and then see what happens. Alright, so it's mounted in. The white wire for the focus to the CRT ran short, so I couldn't run it along the floor like the other one. The other one was kind of sort of okay. I don't really like how short this is either. It really needed to be about 6 inches longer. Hopefully that won't cause any problems. I've got the high voltage button all back together with the leads in. We'll redress everything and hook this thing up. And hopefully that will fix the focus problem. I'm pretty sure it will. And then after that we can focus on doing the setup adjustments. Last thing will be the sound. I know the sound's still dead, but that's a whole nother issue out on its own. Alright, so the divider's back in. Everything's wired up. I've got my little test pattern generator here. So let's turn it on and see if it blows up or not. High voltage. Good sign there. CRT's coming up. Much sharper snow. That's good. Alright, so there's our color bars, our rainbow pattern. Let's see. So we're going to let this warm up a little bit. But we can see now that we have focus, which is good. I've got the focus pot at the midpoint, so it's looking pretty good so far. Let's crank this up. This custom picture, aka contrast. And we see that we have some convergence errors here, but that's what we're going to do next, is tweak that. So let me see if I can get the focus better now that we have a focus pot. Oh yeah, there we go. That's pretty distinct. Much better. So we're going to work on converging this now. We can see that on the side here we have some definite error. In the middle is not great. On the right side also not great. But we do have a nice sharp picture now. And we have good grayscale, or what appears to be. I crank up the brightness. And definitely it's not varying in colors at all, so the CRT is a little used, but okay. Now, unlike delta gun tubes, where you want to converge red and green on top of each other before messing with the blue, you want to converge everything onto green, which makes it a little bit simpler. And it's up to you whether you want to turn off one color at a time to converge it. It really doesn't matter to me, but I'll show you what the differences look like. The first thing you always want to do is a static convergence. So we'll do that. That places our crosshair at the middle, and we can kind of converge things on top of each other. Now, the magnets back here, you've got your blue and red static convergence. That obviously is going to take care of your blue vertical and red vertical. These ones down here are labeled horizontals, obviously your red horizontal and your blue horizontal. And just to show you what they do, watch the crosshair, and I'm going to tweak the red vertical, and you can see the line move up and down like that. And then likewise with the horizontal, you can see the line move to the right and to the left. And you can also see that that does affect the blue, so you will have to go back and tweak things as you go. But that's what you want to do first. Now, it might be easier for you to turn off whatever gun you're not adjusting. So for example, we can turn off the blue, and we can converge the red on the green. And so now the red's vertically on top of the green. Let's see about the horizontal. looking pretty good there. And we can go ahead and turn on our blue. And we can see that the blue actually looks pretty good. We can tweak it a little bit, but there really isn't much need for it. And the horizontal is a little bit off, so we can tweak that too. But otherwise it looks okay. Much simpler convergence on these than the delta gun tubes, for sure. Now if we switch to a finer pattern, we can see that the center looks really good. We've got some error on the left side here for sure, and on the top. It's kind of hard to see that with the camera, but you can definitely see some convergence error on those vertical lines there. Camera doesn't want to focus on them, but whatever. That's kind of where we're at. So the next thing we want to do is do the dynamic convergence, and I'll go over the settings on that in just a minute. So looking at the back here, this is your dynamic convergence board, and for the most part it's self-explanatory. You can see they've got a left side, they've got a right side, and they've got a split top and bottom. It's much different than your traditional delta type tube. And you can see that the right one, much like everything else in the delta world, is a slug, which you will need a non-metallic tool for. Do not try to adjust this with an Allen wrench unless you want to destroy it. I get so many of these things in for repair where the DIYer tried to tweak it with an Allen wrench because that's what fit in the hole. And the coil, the core crumbles and it destroys it, and it just makes things so much more of a hassle. So just don't do it. If you don't have the tools, don't do it. Alright, so what we're looking at here, 808, is your red and blue horizontal split up top. That's why it looks like a wishbone. And there's your red and blue bottom split there. And your left side convergence and your right side convergence for the vertical lines. So what they mean by that, if I adjust the left vertical convergence, you can see how the lines split apart, and you want to get them as close together as possible. You don't want to have to turn it too far, or you'll cause some center error that you'll have to deal with. Now there is no horizontal top and bottom convergence adjustments. It's all vertical, so if you have a little bit of error up top or at the very bottom, you're just going to have to live with it because there's no adjustment for it. Now if we turn the vertical top and bottom split, you can see how that separates the lines, and it also messes with the height and linearity, so keep that in mind too. Which is weird, but that's what it does. And then likewise with the bottom, we tweak the bottom a little bit. Not much difference there, so we'll leave that one be. And they are interactive, so you will have to come back and tweak them a little bit. And you can see how that does throw off the corner a little too. So you will have to come back and tweak that. You want to get the best picture from about maybe a couple feet. It's not going to be perfect and uniform. It's not a flat face tube. It's not perfect. The roundies converge better than the rectangular ones do. But as you can see, it looks kind of sort of okay. We don't have any egregious errors anywhere on the screen anymore. There's a little bit of an error here, a little tiny bit. I'm going to go get my alignment tool set and see if we can't tweak that out a little bit. So this is what I'm using. These are all the sizes that comes in the kit. You can buy these on Amazon or eBay for about $5 or $6. Just do it. Again, don't go screwing around with the cores with metallic tools. It's a great way to destroy them. So let me get the proper tool out, and then I'll adjust the right side. Alright, so here's the tool. You insert it into the core. And these are a little more fine adjustment. And as I turn it, you can see it getting better or worse. You don't want to turn it too far or it'll affect your static convergence. That's pretty good. So step back, take a look. Looks pretty awesome. And we got our grayscale set up already. So now the next thing to do is tweak the color a little. Now I notice when I crank up the contrast, the horizontal lines look a little bit purple, which tends to suggest to me that I need to turn my green drive up a little bit. And the drive controls on this are on the back here. I still hear that high voltage whistling. So let's tweak this a little. That's also going to mess with my green gun. So we'll have to back off on that a little bit. Dirty pots, dirty pots, dirty pots. Ugh. Still a little bit too green on the grayscale side. Oh, that's why. I'm messing with the wrong thing. Alright. I had it reversed. My bad. The drive is the one on the neck of the CRT. I discussed that in the first video. I should have remembered that. Anyways. Alright, so the green drive is pretty much cranked. So let's turn down the red a little bit. Get rid of that pinkish hue. Turn down the blue a little bit. The auto white balance is kind of correcting for it, so it's not gonna look true to you guys. And then I have to crank the brightness all the way up to get a raster. Alright, we need to start this over again. So let's turn this down. Let's turn the contrast at midpoint. Let's turn the brightness to midpoint. Funny how the vertical lines disappear there. Okay. And let's see who the weakest gun is. Who do I have to crank up the most here? There's green. Oh boy. Okay, blue's the weak link here. Excuse me. While I tweak on this a little bit. Blue is our weak link. So that's the gun that'll get cranked up the most. I don't think there's a sub-brightness control on this somewhere. Maybe there is. Let's look in the back. Sub-brightness, anybody? Anybody? There we go, brightness range. Okay, let me grab my screwdriver here. And I want to turn up the brightness range until I just get some blue on the screen. There we go. Alright, so our blue gun's tired. Now we can see a little bit of error on the top and bottom here. Let's see if tweaking that helps. Not really. Alright, so now we'll do the red. Let me get a tool. There's not enough to bite down on as far as turning it with your fingers. Sorry for the dizzy camera effects. And let's crank this. Assuming it wants to. Really? Okay, so maybe our red's the weakest link. Yeah, red's pretty weak. Alright. This CRT is a little more tired than I thought it was. Okay, so back to the brightness adjustment. Alright, that's max. That is maximum. Yep, that's maximum. Okay. A little more tired than I thought it was. Alright, so we'll have to adjust around that one. And let's bring up our blue again. There's our blue to make magenta. Green's is the strongest one in this set. You don't have to turn that up much. Okay, let's get rid of the hint of red that's in the picture. Not too much. There we go. Alright, so there's our grayscale picture. At least I have some more brightness range now, that's good. This CRT is very tired. Much more tired than I thought it was. Okay, so now let's go ahead and let's play with some colors. Ugh. Yucko. Blanky blanky. Alright, let's turn up the color. Increase color intensity. Why do I have no color? I have colored snow. Is the fine tuning just not working? Let's see. Let's hope I don't electrocute myself. There's no fine tuning knob on this set. Somebody has removed it. Alright, let me tune this thing in. Alright, so a little bit of fine tuning work and we got our color. It was showing the rainbow earlier, but it wouldn't show the bars for some reason. Well, anyway, I don't think the phasing is right here because normally this is supposed to be like red, but I have to crank that all the way over to get that to be red, and then I'm out of adjustment. So let's put this at midpoint here and see if there's a sub-tint adjustment or anything like that, because I shouldn't have to put that all the way over. And let's see here. Sub-tint. Sub-tint. Yeah, I don't see anything. Color killer. Horizontal, vertical, blah, blah, blah. Not seeing anything for tint adjustments. I mean, there might be something on the board, but I'm not seeing it. They've got a 3.58 adjustment down there, but that's not what I want either. I guess that's just going to have to be how it is. We're just almost out of adjustment on the tint range. Alright, so the last and final thing to do is hook it up to a converter box, look at the picture, and see how pretty it is. And then the only thing that'll be left to do is the sound, which will be for another video. Alright, well, it's looking pretty good now. Nice sharp picture. Still no sound yet, but the colors are good enough. Sorry for the blanking, it is a little on the bright side. Let's see if I got the sync right yet. Yep, pops right back in. Had a little issue with the horizontal not locking in, but an adjustment took care of that. It's got a little bit of overscan, but other than that, the colors and everything looks really good. The red gun's a little tired. I've got that maxed out. The blue's not too far behind, but it still has plenty of brightness and it doesn't defocus when you crank it. Actually, it looks really good. So I think I might just leave that one alone. Looks pretty decent. It shifted to the left a little bit. Not bad. No sound yet though. We definitely got to work on the sound. I think the sound is very likely due to this little IC over here. You got this IC in the sound section. That guy there, that's your sound processing, and that's your audio output there, which then goes to a driver transformer behind here. And that could be your output transistor there, which could be open. So that'll be for another video, but for right now, it looks good. It really does. So we're going to leave it at that. I checked the griplets and tapped on the board and stuff like that, and it doesn't show signs of griplet disease, so I don't think I'll have to take the boards out and fix the griplets. That must have been done when it was last serviced. But overall, the focus is razor sharp, convergence and color's pretty good. I think we'll leave it at that. So the next part of the video will be for troubleshooting the sound. Stay tuned, more stuff to come.